Greetings, hello, welcome. Let's plot some more rational functions. Let's say you're given g of x is equals to, let's say, x over x squared minus x minus 2. And you're asked to sketch this function, sketch this graph. Okay, first thing that we need to do is write the denominator in terms of its factors. You can use a quadratic equation to get the factors, or you can just go on right away and use intuition. But with experience, you'll be able to do this with ease. Just find two numbers, if added they give you minus 1, and two numbers if multiplied they give you minus 2. In this case it will be minus 2 plus 1. Okay, so to sketch it we need to find the vertical asymptote first. And the vertical asymptote lies at the zeros of the denominator, and the zeros are x is equals to, we equate the denominator to 0 and get the values of x. So x is equals to minus 1 and x is equals to 2. So that's where the zeros lie, and that's exactly where our vertical asymptote will lie as well. So do we have a horizontal asymptote for this graph? Yes, we do, but only in this case, because the denominator is of a higher order compared to the numerator. In this case, the vertical asymptote will lie at y is equals to 0. Okay, cool. So let's plot. Oh no, one more point, not two more points. X-intercept when y is 0, we get the x-intercept. So equate the entire equation to 0. That will give us x is equals to 0. So at 0, 0, that's y-intercept is, x-intercept. So y-intercept, okay, let me just show how I got that 0. Okay, want to get our x-intercept, we equate the whole equation to 0. X is equals to x. 0 is equals to x over x minus 2, x plus 1 multiplied by x minus 2, x plus 1. We do the same here, multiply the 0 by x minus 2, x plus 1, so this whole thing becomes 0. This and this cancel out, it's 1, therefore x is equals to 0. Okay, that's how I got that. Alright, y-intercept, we substitute the value of 0 for x, and then what we get is a y-intercept. So y-intercept is equals to 0 over 0 squared minus 0 minus 2. So 0 divided by minus 2, that is 0. So x and y intercepts are 0. Okay, so we have our intercepts. Now we can plot our graph. and you can plot it on the Cartesian coordinate. Okay. Our vertical asymptotes of 1 and -1 and +2. So -1 and 2 and 2. We get our vertical asymptotes. Horizontal asymptotes are at 0. So horizontal asymptote somewhere, at 0. Minus infinity, minus infinity, going up all the way to positive infinity. Okay. So now we plot the graph. Look at the intercepts. Okay, x-intercepts, they're all at 0, 0. So at the origin they're at 0, 0. Okay, cool. Okay. It's also, I don't know where the graph lies. So I need some extra points in order to determine where the graph lies. I'll get some points on this side just to observe the behavior of the graph on the negative side of the vertical asymptote. How does the graph behave? So let's find out when x is -2, this is negative, and -3, what is the behavior of our graph? Okay, so f of x goes to -2 divided by -2 minus -2 -2 plus 1 gives me -2 divided by -4 multiplied by -1 -2 over 4, which is the same thing as -1 over 2. So when x is -2, the graph is, when x is -2, the graph is, well, y is equals to -0.5, -0.5. So you can already see right here, it's in this region. If x is what if x is -3? Okay, let's test it out. -3 over -3 minus 2 multiplied by -3 plus 1 gives me -3 over -5 multiplied by -2, -3 over 10 over 10. So this is 0.3. So -0.3333 recurring. So negative 0.3. So this is sufficient to tell me that the graph behaves in this manner, in this region. Cool. So we have it there. So what's the graph's behavior in the region? Okay, at 3. Let's go, just go ahead and we'll find it out. 3 minus 2, 3 plus 1. It's 3 over 1 multiplied by 4. 3 over 4. 0. Okay. 0.75. 0.75. 3 over 4. Just prove that. So now this 30 over 4 goes to 0.430. Okay. 24, that is 6. 28 is 7. 7. Remainder 2. Yeah, so that's correct. 0.75. This tells me it's in this region over here. The lowers approach their asymptotes. Okay, cool. Alright, no holes. Okay, now what's the behavior between the vertical asymptotes? What's the behavior in this region between -1 and 2? Let's look at that. This is negative 0.5. This is 1. Zero, it's 0. What is the value of y at 1? Okay, at 1 we have 1 over 1 minus 2 multiplied by 1 plus 1. Excuse me, 1 over 1 minus 2, that's minus 1. 2, this is, oh boy, negative 1 over 2. Negative 1 over 2 at 1. Okay. What about 1.5? Over 2. So at 3 over 2, what's the value? which is 1.5. 3/2, 3/2, and okay. Let's just do this here. 2/2 plus 2/1, 2, 3 minus 4. So that is 3 minus 4 minus over 2. Minus 1/2 multiplied by 3/2 plus 1 plus 2, 5/2, 5/2. Okay. Over 2 divided by negative 1/2 multiplied by 5/2, it becomes minus 5/4. Finally 3/2 multiplied by reciprocal minus 4/5. Okay, 2 is 1, 2 that is 2, 2 by 3 that is 6, 1 by 5 that is, well, that is the same thing as 5. 6/5. 6/5. That is 1. Remember 1/5. So this is 1.2. 1.2 or negative 1.2. This negative is carried on, so negative 1.2. So 1.5 we get negative 1.2. The graph is behaving in that manner, in that portion of this region. Okay. So what about negative 0.5? What's the answer? What's the value for y? Okay. So if negative 1/2, negative 1/2, negative 1/2 minus 2, negative 1/2 plus 1, negative 1/2 divided by 2. This is minus 1 minus 4 multiplied by 2. Well, 1/2. Negative 1 plus 2. Negative 1/2 divided by negative 1 minus 4 minus 5/2 multiplied by 1/2 comes minus 1/2 all over minus 5/4. In the end we have minus 1/2 multiplied by reciprocal of minus 4/5. We have positive 2, that's 1, 2, that's 2, positive 2/5. 2/5 is the same thing as what? 0.4. positive 0.4. So when x is negative 0.5, y is 0.4. This tells us the graph is behaving in that manner. So on that portion of the region, the graph behaves in that manner. So yeah, that's the graph. That's it for this video.